Yeah, hello everyone. Welcome to Geeks for Geeks practice. So today we are going to see a question that recently came in an interview at Morgan Stanley. But before beginning our today's lesson, can you just confirm that if I'm audible or not properly? Yeah, it will be great if you can just confirm me that if I'm audible or not. All right. Thank you, Jeff, for confirmation. So yeah, let's begin our today's lecture. So let me share my screen. So yeah, as you can see on the screen, we have a question that very briefly says a smallest element, right? We need to find kth smallest element to be precise. Now let's try to understand this question with the help of whiteboard, okay? Then we'll come at this after we are go through the logic and what is the crux in this question, okay? We will solve or rather we'll see the code, each and every line of the code, the explanation of it on the portal itself, that is our Geeks for Geeks practice portal. But in order to understand the question in a better way, let's go to the whiteboard. All right. So we have the question as kth smallest element. Let's read the description. So it is saying given an array ARR and a number k, where k is smaller than the size of the array. Okay, that means I have an array ARR, which is this array. Okay, and we have a value k given to us, which is lesser or smaller than n, right? The value or the size of the array. Now, what is it asking? It is asking that we need to find kth smallest element in the given array. So if you have a look at this array carefully, the elements are 7, 10, 4, 3, 20, and 50. And the value of k is given as 3. So what is the third smallest element? Like the very first smallest element is 3, then we have 4, and the third smallest element is 7. And that is your output, right? So that is why they are saying that they will make sure that the value of k, okay, value of k is smaller than the size of array. That means always k will lie in the range of the length, right? So we don't need to worry about whether we will get any absurd value of k or not. We just need to find out if k is given to us and an array is given to me, how can I find out kth smallest element in a given array, right? So yeah. Now let's try to develop the logic for this question. All right. So what comes first in our mind when I have a look at these kind of questions? So the very first thing that comes to my mind is, what if I get this array as sorted? By sorted, I mean to say is, what if I sort this array and I have something like 3, 4, 7, 3, 4, 7. After that, I have 10, then 15, then 20, right? So we have this array sorted. Now, if we have sorted this array, we can straight away return the kth element, right? Kth element, or I can say if I go with terms of indexing, so indexing starts from 0, right? So I should return k minus 1th index, right? K minus 1th index element at this position, right? Because indexing is from 0. All right. So this is one possible solution, okay? And the time complexity for this will go in terms of n log n, as we are going to use comparison-based sorting. So n is basically the number of elements given in your input. All right. I think we can optimize this. We can do better than this. Okay, let's see how. Let me take a fresh page for that. And before doing so, let me just copy this input so that I can use it in my fresh screen. Yeah. Okay. Let's try to think of something better. See, we already have a solution. What is my first solution? I'll write it down. First solution that I have is sort the array. Right. Sort the array and return the element at k minus 1th index. Why k minus 1th? Because indexing is always 1 less than the number. Because suppose if it is said over here k equals to 3, if we, I've already showed it in the previous slide, but just to make things a bit quick, it will be 3, 4, 7, 10, 15, 20. So this I have sorted. Now I am doing k minus 1 because value of k is 3. But I need to return this element, right? Because indexing is from 0, 1, 2. So that's the reason I'm saying that I return k minus 1th. They return the element as k minus 1 is k minus 1th index, right? All right. Okay, let me erase this. So this is my first approach. My first approach is done. Let's have a look at second approach. Okay. So for second approach, we are going to use an adequate data structure. And today I'll be showing you in total three approaches, okay, to this question. And I will go on optimizing it. Like first solution we have already seen, it is in terms of n log n, right? So I think we can do better than this. Let's see, like if we can do that in the second approach or not. So we are going to use heap data structure, okay, in our second approach. Now, in heap also, if I say more precisely, in second approach, I'll be using min heap. Okay. Now, what does min heap guarantees? Min heap guarantees that, let's say, if I have some elements in my heap, okay, then element at the top will be the minimum, okay, of all the elements. It guarantees at least that. It does not guarantee that it will be sorted in ascending order, okay? That is not the concept. But it guarantees that at the top you will have, or the very first element at the top you will have, will be minimum, okay? I repeat it again, it does not guarantee that as a whole it will be sorted, but it always guarantees that at the top you will have the minimum element, okay? So let's try to utilize this fact, okay? So what can I do is, first I will insert all the elements in my main heap, okay? So see how main heap works is, let's say you start inserting from here, okay? So you have inserted 7. Mhm. Now you come to this integer 10. You insert 10 over here. Now you have 7 and 10 both, right? 7 and 10 both is there in your heap. So how come this 7 and 10 will be arranged? As there is a main heap, so obviously 7 will lie at the top, 10 will lie at the bottom. After that I come with 4 and I have this time 7, 10, and 4, 3, right? So this time 4 should come at the top, right? Because it's a mini. So I am sure that 4 will come over here. But I am not sure about 7 and 10, right? It could be 10, 7 also, or it could be 7, 10 also, okay? Like I cannot guarantee it is sorted. Like it might be sorted, it might not be sorted, as I said earlier also. But I am sure that this top element will be my minimum. And how these things work? Basically, there is a max ep5 function, okay, or min ep5 function in case of main head, max ep5 and min ep5. And the working of max CP5 and min EP5 I'm not showing right now. We will have a separate lecture for that. Okay. Because that's a totally very deep concept. I need to explain a lot of things before showing max CP5 and min EP5. But I'm just saying the outcome that your top element in case of min heap will be minimum of all the elements. You cannot guarantee anything at the bottom. And if top element in case of max heap will be maximum, you cannot guarantee anything at the bottom. Okay. So if you have any doubts till now, you can ask in the comments. Okay, fine. So for the sake of standardness, let's take it ascending. Okay, but I repeat it again. It is not always the case. Okay, so let's take it like this. Why I'm taking it ascending? Just to keep things simple over here. Okay. Uh, Fine. Let's proceed forward. So I have 4, 7, 10. I have 3. Now once I come up with 3, okay, or let me go till the end. What will happen when I go till the end? So I'll have something like 20, 15, 10, then I'll have 7, then I'll have 4, then I'll have 3, right? Let's say this is my arrangement. See, this is perfectly ascending order, but as I said, this cannot be the scenario. Okay, and why have I written ascending? I'll just justify it in a moment. So please have some patience. So we'll be writing code in such a way that basically an approach to if I write the code, I will be building my heap by inserting all the elements. Okay, and that itself is in the order of n. Okay, that itself is in the order of n. Like build heap takes order of n time. Okay. Now, as I said, this build heap and max heapify, min heapify, this all will take another separate lesson. Like it might take 1 hour or more than 1 hour also in order to explain how this is coming out to be bigger of an. Okay, and I will talk about time complexity of max heapify and min heapify also. So just stay with me for a moment. We'll see. All right. So the very first thing which I'll be doing in my second approach is I will insert all the elements in my main heap, and that is of the order of 10. And after that, this is what I get finally. Suppose this is what I get. This is one potential heap, okay, that I could get like this, or I could not also. Okay? But one thing is sure, I repeat it again. One thing is sure, the topmost element will be 3. That is for sure because there is a main heap. Okay. All right. Great. Now what I'll do is I am asked to find out the kth smallest, right? So what I'll do, I will remove k minus 1 elements. Okay, I'll remove k minus 1 elements from my menu. So if I start removing, I'll have 3. Okay. Now why I was saying that, sorry, if I start remove, I'll pop up these 3. Now this main heap will be rearranged in such a way that it will keep 4 at the top. Okay. Right now you are seeing 4 at the top, but what exactly happens is there is a function, as I said, main heapify. Okay. That adjusts my heap and make sure that once I pop my top element, or once I pop the minimum element, I again make it a valid heap. Okay. Fine. So after that I'll have 4 at the top, that is for sure. Okay. Now we will pop 4 also because we decided to pop k minus 1 elements, right? So we decided to pop 2 elements because 3 minus 1 equals to 2. So we have already popped 1, we'll pop 4 also, right? So we have popped 4. Now let's say if this was in random order. Now it's not. But if this was in random order, this min heapify uh, would have arranged this heap elements in such a way that 7 would have stayed at the top. Okay. So that's it. Like we have popped k minus 1 elements, and after that we are straight away going to return the topmost element. This is one potential solution. Okay, there's one potential solution. Like this one is taking big of n time to build the heap. After that, main heapify will take log n time, okay, or log k I can say, okay. Log k in the sense, let's say k is the number of elements present at that particular point of time in your heap. Okay, so you are doing min heapify how many times? K minus 1 times. So somewhere improvement is there. Okay, somewhere improvement is there. Uh, but I would not say it is a huge improvement from our first approach. Okay? Because first approach was taking n log n. This approach will take big of n plus whatever is the time taken by your min heapify. Okay. All right. Now let's go to the most efficient approach. That is the third approach. If you have any doubts till approach two, you can ask right now. Okay, in the comment section. All right. So as I see that there are no questions till now, uh, let's go to the third approach. Okay. So let me erase all of this. Yeah, but before erasing, I'll just sum up, or rather, let me not erase right now. Let me just sum up. What have I discussed? Yeah. So I have discussed approach one, which was to sort the array, return the element at k minus 1 at index. After that, I discussed approach 2, which was using a min heap, where I was first building my min heap with all the n elements, okay, like building my min heap of all the n elements, and I was just deleting k minus 1 elements from it. And as it is the property of min heap, so it will always keep the smallest element at the top, okay. So eventually, I was getting 7, which was the potential answer for this particular test case, right? After deleting two elements because the value of key was 3. So just to repeat the very key thing, min heap and max heap uses min heapify and max heapify to adjust elements inside it, making sure that in case of min heap you have the topmost element you have the topmost element the smallest one, and in case of max heap you have the topmost element largest one. Okay, so min heap will have the topmost element as smallest one, and maxip will have the topmost element as largest one. It does not guarantee anything about, excuse me, it does not guarantee anything about the rest of the elements. Okay. But in order to show you over here, I have kept it perfectly sorted, but that is not the case. I hope you get a feel, right? Because once I start deleting my k minus 1 elements, after every deletion, it will itself heapify it according to the type of heap. So it will give me the next smaller or next larger element depending on the type of heap on the top. Okay. So in this case, it was giving me the next smaller because it was a min heap. Okay. Now let's discuss the third approach. Yeah. So this is going to be the most efficient approach. Okay, this is going to be the most efficient approach, and we are going to use Maxit in this. Now you might be a bit surprised, like how come Maxit will give me most efficient? Because uh, already we have seen MinHit, right? How come it is possible with the help of Maxit? Maxit. So we'll see that in a moment. Okay, let's see how does it goes. So what we are going to do, we start from our very first element. Okay, 7. Now, as the property of max heap says that I will have the topmost element as the maximum element, so let's say I have 7. Okay. As soon as I am inserting 7, I'm also keeping a check, okay, whether total size, okay, of heap, total size of heap, sorry, just a second. Yeah, whether total size of heap is greater than my value of k, okay. I'm also keeping a check, and I'm also keeping a check whether total size of heap is greater than k. There's a reason I'm doing this. You'll get to know in a moment. Okay, fine. So initially, what is the size? 1. Okay, so 1 is obviously not greater than k, right? K is 3. Fine, fine, great. So after that, I insert 10. Still, this size is 2, and it is 2 is still not greater than the value of k, right? Like value of k is 3. Fine. After that, what do I have? I have 4. Now, as there is a max heap, as I said, like topmost element will be maximum and we don't guarantee anything bottom to it. But for the sake of standardness, let me keep it as perfect descending. I repeat, this could not be the possible scenario, but over here I'm just trying to keep things simple and standard. We will see in the code, okay? I'll try to justify this in the code. But yeah, one thing is sure that this first place will always be occupied by the most biggest element. Okay, fine. So total size is now 3, and the value of k is also 3. Right. Still, this is not greater than the value. Sorry. Still, this is not greater than the value of k. Right. Fine. So I'll go to the next element. I have 3 now. Fine. I have 3. What should I do now? I should insert 3 right over here. So as soon as I insert 3, what does it become? So okay, let me draw over here. Let's say as soon as I insert 3, it becomes this, right? Fine. So as I was discussing that this will play a key role. Now this condition has become true. Total size of heap is 4, which is greater than 3. So what we need to do, we need to pop off, okay? We need to pop off this. Okay. So if we pop off this, it will again max heapify itself and we will have 7 at the top, which is already there. So no issues. We have 7, 4, and 3, right? After that, I get 20. All right. So I'll have 20. Now see, 20, when I insert 20, I again check. So still the size is 4 and the value of k is 3, right? So I need to pop it off because I have just now discussed an approach where I said, excuse me, where I said that if total size of heap is greater than k, excuse me. So I am popping my topmost element. So I'll pop this as well. No problem. Let me come to the next one. I have 3, 4, and 7. And after that, I have 15. So I'll insert 15. Again, the same check. 4 is greater than 3 becoming true. I'll pop off this 15 as well. My traversal ended. And finally, I'm going to return this topmost element. Okay. So how come this approach most efficient? It is because we are not building heap as a whole in total, okay, fully. We are only building heap for k elements, if you carefully observe, right? K elements. And that is not, that also I would not say we are building heap. If you carefully observe, we started from traversal of the first element, okay? So you came here and you inserted. This is like your heap is initially empty and you are max heapifying your heap, okay, or rather you are inserting element into your heap and that internally does the max heapification or max heapify it because that's the property of max heap. So that is in the order of log of k, where k is the number of elements in the heap, okay, at that moment. So at max, how many elements do we have in the heap? Can I say that we have k elements at max? So at max we have k elements in the heap. So whatever rearrangements are done in order to keep the biggest element at the top, okay, that is done only for k elements and the complexity for that is log of k. Okay, we are not building heap as a whole in total. Okay, so this is one thing which you need to observe. So in case of second approach, we were going for big O of n, okay, for building the heap. But in case of third approach, we are not doing that. We are running a for loop, and inside the for loop, okay, if I try to write the structure, how does it looks like? We have a for loop, okay, and inside the for loop, I have a time complexity of log of k, okay, and this for loop is running for n elements. So overall, the time complexity becomes n log k, right? Which is the most efficient among all the three approaches. So do you have any doubt in any of the three approaches till now? You can ask in the comment section. All right. So as I see that there are no doubts, let's move on to the code. Okay. But before jumping to the code, as I am going to leave the logic over here itself for now, I would just like to mention that thing again. Okay, because I have seen many programmers doing that mistake. Okay, mistake in the sense like they assume that if they have taken max shape or min shape, they will get things in sorted. No, it's not. It's not the case. Let me show you like how. Let me show you very briefly how does it looks like. Let's say this is the kind of a binary heap, okay, or a tree. Now, if you are trying to, or rather, I would say normal binary tree. So if you have elements at these places, in case of min heap, this element is the smallest, okay, and in case of max heap, this element is the largest. We don't guarantee anything about rest of these elements as of now, okay. When we will devote a separate lesson to this, then I will teach you how arrangements and all the things are done over here. Okay, like what we can guarantee, what we cannot guarantee. We'll see all of these things later. But in order to just appreciate the use of heap over here. We are utilizing its fact that the topmost element will be smallest in case of mini, and the topmost element will be largest in case of max heap. I don't guarantee anything about rest of the elements. It cannot be sorted or it can be sorted. Okay, you cannot say anything. Nothing can be said. And every time you pop off, it rearranges itself in such a way that again you get the topmost element according to the heap. Okay, if it's min heap, you get the minimum element. If it's max heap, you get the maximum element. So I have shown over here completely sorted in ascending or descending order according to the min or max heap, because I know that once I pop this 10, this 7 will come to the top because there is a max it, because rearrangement will be done. So as I don't need to draw separate figures, I have showed it in this way. Okay. So I hope this is making sense to you. All right. So let's get to the code now. Okay. Yeah. So I am basically using approach 3 over here. Okay. The most efficient approach. The rest of the two approaches I have already discussed in the logic. If you want the pseudo code for them, or if you face difficulty in applying those two approaches, you can comment it down. Okay, I'll reply back. But over here, I'm implementing the most efficient approach. Okay. So yeah, in case you want the pseudo code for the first two approaches, you can let me know in the comment section. Okay. Yeah. So as you can see, I have taken a match set, and we are using a priority queue for that. Okay, which is of type integer. Right? Like integers are stored in the priority queue, and there is in Java we have collections framework, and this is how we declare a match set. Okay, uh, we have to write collections dot reverse order. If you don't write this, Java gives you by default meaning. Okay, so in order to make it a match set using priority queue, this is the syntax. All right. Now, as I discussed in approach 3, what I am doing, I am going through each and every element, okay, and I'm adding it, and I'm also checking after addition. Is my size got incremented by the value of k? If it is, pop it then and there, okay, pop it then and there, and do the same for rest of them. So I have already done a dry run for this. You can go back and you can go back to the video and watch it again if that is not clear to you. Or if you want, I can quickly try run it over here also, not an issue. Let's see one second, like, very quickly, if that's required. So just give me a moment. Let me take that input, okay? So the input is 7, 10, 4, 3, 20, 15. Maximize the size. Yeah, paste it over here. Yeah. So we have 7, 10, 4, 3, 20, and 15, right? Now, initially your priority queue, which is implementing your max step is empty. I start from I equals to 0. I add my 7 over here. Right? I add my 7. After that, I check the size. It's not exceeding because value of k was 3. The size is 1. Right? So this is false because if you see 1 greater than 3 is false. Right? So it's not exceeding. So you go up again, you add 10 this time, right? There is a max step, so 10 comes top. This it is still not exceeding. You go up again, you add 4. Now this rearrangement will be done now. Okay. How come this rearrangement will work? This will be something like this. Like this could be one possible rearrangement. There could be also 10 4 7. Okay, or 10 7 4 as you could see. I'm just trying to make a point that at the top I have the topmost right. I have the biggest every time. Okay, that's great. No problem. So let's proceed further. After that, I have this 3. Now, as soon as I have this 3, yeah, and one more thing. This is not yet become 2, right? Because we still have the size not greater than k, right? So as soon as I have this 3, what will happen? This will again rearrange. I'll have 10, 7, 4, 3. Okay, fine. Now, yeah, like as you could see, I've written in perfectly descending order. But see, I know I have told it many times in this lesson, and it's a very important interview question also. That's why I have told it. again and again, right? I'm writing it in descending order, but don't take it like this. I'm just making sure that I have topmost as the largest one. Okay, rest things can vary. Fine. So I have max dot size greater than k. This is becoming true now. So I'll pop it off. I'll pop it off. It will rearrange. It will keep 7 at the top. Okay, already 7 is there. Every time it is ensuring that I am a maxi. Okay, so hence we have 7 at the top. Now we have 7, 4, 3. You come up with 20. It is again popped off because size is greater. You come up with 15. It is again popped off because size is greater. Okay, 20 is not there. You come with 15, size is popped off, and finally you're out of this loop. And you're returning max seed dot peak. That is whatever is at the top node. So you're returning this 7. So as I said, like this is running for n times, like error dot length. And this is at max doing your log of k work. Okay, because at max you have k elements in your heap. Right? So the time complexity becomes n log k. Right? Initially, for the first approach, it was n log n. We have improvised a lot because k will be smaller than n, right? It was mentioned in the question also. In worst case, like k might be like it might ask the very last element, but for average time complexity, if we see like if we get multiple queries or multiple inputs, I think there's a better approach, right? Fine. So I hope this is clear to you. Okay. Let me know if you have any doubts till now. Okay. As I see that we don't have any doubts as of now. Fine. Then let's just summarize our today's session. Okay, let's see what we have learned. Let's go to our Geeks for Geeks practice portal in order to submit the code. Result status empty or failed while processing results. Is there any issue with the server? Let's try to compile it first. Okay, it is getting compiled. Output was 7. Let's see if this gets submitted this time. Yeah, so there was some issue with the server, right? We get the correct answer now. Fine. So what was the crux in this question? The crux was to improvise, okay? Like anyone, or I would say at least someone who has basic knowledge of sorting can come up with the approach that, okay, fine, we'll sort it in ascending order and return the corresponding element at the k minus 1th index. But we improvised it. We saw an approach with many. We saw one more approach with maxi. Okay. So these kind of questions, wherever you see kth smallest, kth largest, the first thing which should come to your mind is whether can I apply a heap implementation or not. Okay, like why I'm saying this because in my every live lesson I try to give a crux. Okay, crux or rather some key point which is really important in such questions. Like let's say if you have solved 50 questions, then your data set is somewhere ready that you start recognizing questions and you can say that okay, this is a question of stack, this is a question of heap, this is a question of queue, right, and so on. So if you see somewhere kth written, kth smallest, kth largest, okay, once you should give a try of heap. Okay, this is just a suggestion. I'm not saying that it will work every time, but I am just saying that instead of going completely blank, you should once give a try that can I solve this with the help of heap? Okay, whether max heap or min heap, it's your call. You need to see which one is efficient. Okay. Similarly, like if I reverse this question, kth largest heap, sorry, kth largest element, then give a try by yourself. Which heap if I use will be more efficient. Okay. And how can we do that? So this is one thing. Yeah, and apart from that, before ending today's session, I would just like to end it on a note that heap has two operations. One is build heap, other is max heapify or min heapify according to the type of heap you have. Build heap builds your heap provided you already have the n elements stored. Okay. Max heapify or min heapify works in a way that elements are coming in my heap again and again, and it is rearranging, making sure that the property of heap is satisfied. It is never violated. What is the property of heap? If it is a min heap, the property is that at the topmost position I'll have minimum element. Like I'll have minimum element if it's a min heap, and if it's a max heap, I'll have maximum element at the topmost position. Okay, but it does not guarantee anything about the bottom elements. Over here, while discussing my logic, although I showed sorted sequence, why? Because I did not want to draw the figure again and again and confuse you. It is just because if you now look at the code, you better understand, right? See line number 44. This will automatically keep on heapifying things for you, or if you look at line number 47 also, if you even if you poll, even if you remove element from your max heap, still it will rearrange so that in the next iteration of for loop, you will get maximum element at the top. Okay. So I have drawn only one, I guess not one, but very less number of heap structures in my today's logic, and kept all of them as sorted because I am assuming that max heapify will doing it for me again and again in my every iterations. Okay, and whenever I try to remove or add element to my heap. Okay, still if you have any doubts, you can ask in the comment section. Okay, yeah, so that's it about this question. Okay. Like I'll wait for a moment, like if you have any doubts then you can let me know. All right, so as I see that we don't have any doubts, so the key takeaways from today's lesson was how does max heap and min heap works internally. Okay, how to tackle efficiently the kind of questions where we are asked to find out kth smallest. Okay, one variation could be kth largest. Okay, and in these kind of questions, if it's in an interview, and if the interviewer asks you to improvise your solution, then if you are not aware of the heap data structure, then I think it will be difficult for you. Okay, to do that. So you should practice these questions. Okay, and yeah, and just to wrap it up, the most important line of today's lecture was that is even that can be even asked in interviews. Like if you are storing elements in maxheap or menheap, are all the elements stored in sorted sequence? No, that is not the case. It only ensures that the topmost element in case of that it only ensures that topmost element in case of maxheap is the largest, and topmost element in case of menheap is the largest. Menheap is the smallest. Okay, rest of the elements, it does not guarantee anything. That max simplify does for you in every iteration, as we have seen in this code. Okay, fine. I know that I have said this multiple times, but I have seen people getting tricked over here. Okay, that's the reason I have said it. And I have drawn I have drawn images of heap where things were sorted, because I was assuming that max AP5 or min AP5 would do it for me in iterations. Okay, in every iterations. Still, if you have any doubts, or if you want to learn more about max heap, min heap, how does heap is built, okay, you can comment it down. We can look forward on having a lecture on it also. Okay, like totally a separate lecture on heaps. Okay. So I hope this code is clear to you. Yeah, so still there are no questions, no problem. So fine. All right. All right, thank you guys. Joining. Thank you for joining Geeks for Geeks practice. We will come up with more questions from uh, recently asked set. Okay, from product-based companies. So in the upcoming days, and yeah. All right. So fine. I'll just wait one more minute. If I get any questions, it's fine. Otherwise, I'll end the broadcast for today. Yeah. Before ending, in the meanwhile, if I get any questions, it's fine. Otherwise, you can go to our channel, Geeks for Geeks Practice. Okay, and there is a playlist where we have clubbed all the questions that are recently asked in product-based companies. So those questions basically comprises of separate data structures. Like what we are trying to do, we are trying to make a playlist which is in which you get variety of questions. Like for example, today we talked about heaps, right? And similarly, there are questions on stack. There are questions on binary search, like different algorithms, different data structures. There are questions on linked list. So we are trying to uh, tackle questions in such a way, like if you do one question, you will be able to do three, four more. Like if I give you today's example, now we have done kth smallest element, right? You can give a try to kth largest element. In the last session, we have done a question from linked list, okay, like how to detect the middle element in the linked list. So with the help of that slow and fast pointer approach, you can also have a look at the question of detecting loop in a linked list. Before that, I remember we have done one question on stack, finding the next greater element, okay. So there are also variations to that question, finding the next greater element to its left. Okay, we have done finding the next greater elements to its right. Similarly, next smaller element to its left, next smaller elements to its right. Okay, yeah, next smaller elements to its left, and so on. So my point is, like, we are taking up questions in such a way that you will get an idea. Okay, you will get an idea from our one question how to do three four more questions. Okay, we are not trying to go with similar question every time. And if you have any doubt in any such questions, or if you have any doubt in data structures, understanding any one of them, okay, like today I have discussed a lot about heaps, right? So if you're not, and if you're not, let's say, if you're not able to understand how max hippify or min hippify works, then you can separately comment it down. We will plan to take a lesson on that. Okay. Yeah. So that's it from my side. Okay. Yeah. Thank you, Yuvraj. Thank you for your kind comment. Yeah. Yeah. Okay. Thank you, Yuvraj. Yeah. All right, guys. Then see you all in my next live lesson. Thank you for joining Geeks for Geeks practice. Yeah. Thank you, Yuvraj. Okay. Yeah. 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 You can have a look at the playlist, and if you have any doubts, you can let me know. Okay. Okay, guys. Thank you for joining Geeks for Geeks practice.